Good afternoon, class. This is geometry. We're in chapter 1 and section 5, measuring and constructing angles. We're going to be talking about angles. Up to this point, we've been talking about undefined terms like points, lines, and planes. We've been talking about segments, some formulas, and calculating midpoint and distance. And then we've talked about perimeter and area. So now we're going to talk about the angles that make up basic geometries. We're going to start out with some vocabulary. So let's start out with an angle. An angle is made up of two rays. And those two rays, they start at the same point. And that point is called the vertex here. The rays go out, and each one is called the side of an angle. So an angle is defined by two rays with a common vertex, and the rays are the sides of the angle. There's also this concept of the interior of an angle. The interior of the angle is the smaller of the two angles. So you could have, you could actually consider that this outside area here is also an angle, but that's called the exterior. So the interior of the angle is usually what we're most interested in, and that's the smaller of the angles. Now, there's one thing to consider. What if the angle is 180 degrees? So the rays are pointing away from each other, and it's 180 degrees. Well, that's called a straight angle, and there are no interior. There is no exterior. So that's the one exception. Now, naming an angle, there are different ways that we can name it. We could very easily just use the vertex, and in this case, the point of the vertex is called A. If I said angle A, it's unambiguous to note that this is the angle that I'm talking about. These are the two rays, and this is the angle, this is the interior, so this is the angle we're talking about. We can also use a point or a couple points on the rays. So I'm going to have a point B on this ray and a point C on this ray. Of course, I have my vertex, and I can call this angle, the same angle that I just called A, I can call it BAC, angle BAC, which is just as unambiguous as using just angle A. I can also call it CAB, so I can flip it around and it still makes sense. Another way that we can name angles is sometimes what we'll do is we'll put some kind of letter here or number right in the angle itself. And whatever that is, then we call the angle that number, so angle 1 in this particular case. So you can see with this one angle, we can actually name it different names and they all mean the same thing. Now let's take this figure. Here we have a quadrilateral, it's a four-sided figure, and we've got these points, all these vertices named here. The problem here is if I say angle B, it's not clear whether I'm talking about this angle from this side, BC, down to BP, or I'm talking about BP over to BA, or I could be talking about this whole angle from BC all the way over to BA. So that's kind of ambiguous, and the same thing with D down here. The way that we can deal with that is if I have an unambiguous angle, I can call it just angle A. So you can see A and C are unambiguous. And if I want to specify, say, this angle right in here, then what I can do is I can just say the angle is ABD, and then it's unambiguous. We know that is the angle we're dealing with. So that's the naming of angles. Make sure that you don't use ambiguous names. If you say B, nobody's going to know which angle you're talking about. There's three different angles there. The measure of an angle is done with what we call a protractor. So right now, what we have is this ray that's going out this way, and it's going to be level on the 0 line of the protractor. So a protractor has this point in the center, and you've probably used protractors before. So we have the vertex at this point, and then we have one of the rays that's going on the 0 line. This is actually called the terminal part of the angle. That means it's the starting point. And then the other ray is going to be somewhere along one of these numbers here in the protractor. So in this particular case, if I look, if this starts at 0, I'm going to count up 10, 20, 30, 40. 90 degrees is straight up, and then I just keep on going, and this one happens to be 140 degrees. So the measure of AOB is also is going to be 140 degrees, and we write this as M before the angle's name, angle AOB, AOB. Now, the difference of the angles is the difference in where the ray position is relative to the protractor. So that's how we do the measurements. Don't get this confused with the bigger numbers here. Now, some of these protractors, they go both ways. Here's 180, and then it counts down. This is not 40 degrees. This is 140 degrees. Let's talk about the types of angles. There's the acute angle. You probably heard of these things before, so this is just review for most of you. Acute angle is an angle that measures greater than 0 and less than 90 degrees. Anything that's, if it was 0 degrees, that's not an angle because both rays are pointing in the same direction. And if it's exactly 90 degrees, that's some other type of angle. So acute is something greater than 0, less than 90. Sometimes we call that from 0 to 90 exclusive. That's kind of a big word. Sometimes you'll hear that, but let's just keep that in our back pocket. Then we have the right angle, and the right angle is where you have the two rays exactly 90 degrees. Obtuse angle, well, as you probably already know, it's greater than 90 degrees, but it's less than 180 degrees, so it's inside of that. It's no greater than 180. And then finally we have 180 degrees, and that is called a straight angle. And a straight angle, like I told you before, does not have an interior, does not have an exterior. Whereas all these other angles, you can see very clearly that it has interior and exterior parts of the angle because they're less than 180 degrees. Whereas a straight angle, there's really no difference. Both sides are the same measure. So we're going to do a construction, and this is something that's going to have to be done in class, or you can look in your book. The construction is in chapter 1, section 5, and you can follow the instructions there. While you're doing this, it would be a really good idea to write down the steps that you're taking. So if we're going to construct what's called congruent angle, which is copying an angle, we're going to take an angle that already exists, and then we're going to somehow construct it somewhere else on the paper. And it can be any pointing in any direction. It could even be pointing in the opposite direction, as long as we're copying the angle itself. And I will leave that to you to go and practice that. Now here's a little challenge. I'm going to give you two angles. I'm going to give you PQS, and I'm going to give you SQR. Now you can see right away S and Q are really the same ray. It's just that I drew them at two different places. What I want you to do is I want you to copy these angles in such a way that you create an angle PQR, PQ to R, so that S is in the interior. And I want both of these angles to add up to the final angle that you get. So that's a challenge for you, and why don't you stop the video and try that out on your own. Now we'll continue. First postulate. So we've been learning a lot about angles. Now we're going to talk about a postulate. We've learned about the segment addition postulate, and that's where the sum of the parts are equal to the whole. Once again, the angle addition postulate is the same thing. So if you have two angles and they're adjacent and they're planar, then the measure of each one of those angles added together is equal to the whole angle that they make up. So in this particular case, I have a smaller angle here, RSP, and I have a smaller angle, PST. When I take both of these angles and I make them adjacent, and they're planar, of course, then the measure of the two small angles added together is equal to the angle, the total angle here, which is the big one, RST. It's pretty intuitive, but it had to be stated as a postulate because remember, way back when, Euclid had to state things in a very simple way so he could build arguments all the way up until he got to more complex things. So the angle addition postulate, if point P is in the interior of RST, so this is the formal postulate, if P is in the interior, then the measure of the angle formed with ray SR, so RS and then P, and the measure of PST are added together. It is equal to the sum of the measures. Then the measure of RST is equal to the measures of these two smaller angles added together. Angle bisector. So now that we have an angle, now let's talk about dividing it into pieces. One way that we can do that is we can bisect it. And bisecting it means that we're going to create two congruent angles, two angles that have exactly the same measure. So no matter what angle I have, the interior can be divided into two equal pieces or two equal angles. And in this particular case, if I want to show that an angle is congruent, I draw this partial arc here, and I drew a partial arc here. And these mean that these two angles are the same measure or they're congruent. So then in this particular case, YW bisects this total angle XYZ so that the angle XYW, this angle here, is congruent to WYZ. So now we have two congruent angles. And you can do that with any angle. That's called bisecting an angle. We can say that YW is the bisector, or the angle bisector, of this total angle XYZ. Doing an angle bisection construction is also an important thing, and you need to learn how to do that. It is also covered in Chapter 1, Section 5. You can go in and read about that. Once again, you should be writing down the steps that you take. Step 1, draw an arc. Step 2, and 3, and 4, and so forth. When you write down these steps, in my mind, if you write something down, then you have a better chance of remembering it. If you don't write it down, well, you're kind of taking your chances. So go to that section in the book, and I will wait while you do a construction of an angle bisector. All right, everyone, let's continue on. That concludes our session on measuring and constructing angles. The homework that you're expected to do is here. It's homework number 5. So make sure that you do that homework and be ready to turn it in and ask questions the next day that we get together. For now, Mr. Greenstein out.